so far. Okay, so I invite you to get your notes ready. Title it word problems. Okay, and here we go. Okay. When given a word problem, you will have to read and interpret the question in order to create inequalities or an inequality. You have to be careful to ensure that you write the correct number of inequalities presented by the problem. Let me see if I can focus once. Hold on. There you go. Things to keep in mind. Number one, the type of data. Right? It can be discrete, and if it's discrete, can only exist as a whole number, right? Can only be stated as a whole number, right? Example, people, coin or coins, cans, etc. Okay, so there is a difference between discrete data and continuous. Does that ring a bell? No, it reminds me of APR. Continuous can exist as a decimal or fraction. Okay. I call it continuous as anything you can measure, right? Examples, money, distance, temperature, time, etc. So sometimes you're going to have to round because it's the problem, the question implies that it's discrete, right? Like they're asking you how many, the number of cans or the number of whatever. And sometimes it's, you can just leave it as a decimal or fraction, right? So that's something you need to remember. And then down here, when you state corner points, comma, where data is discrete, you will have to round. Example, if you use your calculator and you get 2.36, 5.45, right? We're going to round to 2.5, but I want you to actually show me the decimal and then the rounded version of that. Okay, so if you're talking cans, large cans, small cans, you can't leave it like this. You have to round it to the nearest whole number. Number 2, almost all cases involve data that cannot be negative. Therefore, your resulting graph should not include negative values. It kind of goes back to quadratics. Obviously, there are exceptions, right? If something like a bird dives under the surface of the water, it is implied that we will have negative values, right? But for the most part, we don't. We have positive values. So you shouldn't have all 4 quadrants on there, that's for sure. Okay. So no context, right? If there's no context, we would just simply have, right, quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then context, meaning word problem, let's say you have people here and floor space required, right? And so you would, now there's a context there. Before you just had them every which way, right? So I'm gonna use a red and a blue pen here. There we go. So let's say under the, like if you were to just graph that equation, no word problem attached to it, you take, right, you graph like this. It spans over all 4 quadrants, right? And then you graph your second inequality or line. And it goes like this. Oops, is this pen dying? Right? No context, it would look like that. If there's a context, and you, obviously the inequalities are going to look the same, you actually have this happening. You would just show this portion of the graph, right? Whatever happens in quadrant 1. So you kind of zoom in and do one of these. Okay. So that's the difference between even a quadratic, right? If a quadratic doesn't have a context around it, you do all, like you graph, you span it over the whole thing. If it's a context, you're most likely just going to park there under that, okay? All right. So now we're gonna practice turning words to inequalities. Let X be people. If the question would say something like this, and this doesn't span the whole thing, but if it says no more than 40 people are allowed, okay? Let's just write them all down, then we'll convert them. So no more than 40 people, at least 10 people. We're gonna stop doing the people because we'll get the point, right? A minimum of 20 people, at most 37 people, up to 100 people are allowed. So these are all like ways, as soon as you see keywords like up to, at least, no more than, like all those, that's a indication that this is going to be an inequality. So we know that X represents the number of people in this case. It could be the number of cans, the number of pants, the number of jackets, doesn't matter. But if it says no more than 40 people are allowed, right, that means that the number of people, look carefully, the number of people has to be less than or equal to 40. That's how you would translate this word and the words into an inequality. You can have no more than 40. You can have up to 40, right? But no more. So the number of people, which is represented by X, has to be less than or equal to 40. The next statement says at least 10 people. So the number of people has to be greater than or equal to 10, right? This would say, hey, the number of people is represented by X has to be greater than or equal to 10. That way you're saying that you're going to have at least 10 people. Okay. A minimum of 20, it's kind of saying the same thing, like at least or a minimum of. That means that X would have to be greater than or equal to 20. At most 37. At most 37 is very similar to up to 37. So X would have to be less than or equal to 37. This statement says that you can have up to or at most 37 people. Same thing here. Up to 100, X has to be less than or equal to 100. It can go up to 100, but it has to be no more than, right? So the same statement would you could write it saying no more than 100 would have the same inequality written as there. Okay, so you have to be very careful how it's written. And I think I'm going to stop there because the bell is going to take us.